Hello friends, welcome back. Good evening one and all and welcome to YES Preparation League. And we are in day 3 SSC JE RRB JE Basic Electronics part. And today I'd like to continue the questions part of digital electronics. It takes 5 to 10 minutes and after that we'll go for one simple topic from basic electronics as I told you in yesterday's class, right? And then we'll go for some of the simple questions in that. Yeah, before going to give you the question, see, I'd like to give you some basic information about XOR and XNOR operation of two variable function. F is equals to A bar B plus AB bar. By look at this expression, you can understand that given is a XOR gate, Boolean expression which is obtained by exclusive OR gate. I can write it as A XOR B. And the question is, if F is equals to F complement, find its value. Find its value. Okay. We can do it in two different ways. We can directly write the complement, or otherwise we can take the whole bar and we can go through the De Morgan's theorem. Right. F is equals to A bar B plus AB bar whole bar. Apply De Morgan's theorem, A bar B whole bar dot A B bar whole bar. Again we can write the De Morgan's here, okay, A plus, how can you get A? A bar dot B whole bar, right? So, A bar whole bar plus B bar, bar and bar get cancelled. So, it will become A and this will be B bar dot A bar plus B double bar. We can write it as A into A bar, 0 plus A into B, AB. B bar dot A bar or A bar dot B bar plus again B dot B bar will become 0. Then if you observe the function carefully, what did you get? AB plus AB plus A bar B bar is nothing but exclusive NOR operation. This is the output of a XOR gate. AB, I am writing the symbolic representation, and this is a exclusive OR gate with the bubble. You know well, this is exclusive NOR gate. Exclusive OR and exclusive NOR. Right? What did you get? Complement of XOR means after bubble, after completion of XOR operation, if you add a bubble, it will become XNOR. So, this is an exclusive NOR operation, A XNOR B. And this is actually the relation for two variable case, like 2 input XOR and XNOR. In 3 input case, the story is completely different, but now we are just talking about the 2 input XOR gate and XNOR gate. This is more than sufficient for us. Okay. So, finally, we can write a conclusion also like this. A XOR B complement can gives A XNOR B. And similarly, reverse is also possible. A XNOR B complement can gives A XOR B. A XOR B whole bar. A XOR B complement will give XNOR operation. XNOR complement can give XOR operation. Okay? And you better to know the truth table of XOR and XNOR gates. But in the next session, I will give you the logic gates idea, and in which I am going to give you truth tables of all logic gates. Then if you go for 2 input and 3 input XOR gates, their truth tables, and then you can easily understand if one input of XOR gate is connected to like plus 5 volts, what is the behavior. Indeed, that particular circuit will act as an inverter. If one input of XOR gate is connected to ground permanently, what is the behavior? You can find these kind of questions. But now we are not in logic gates, we are in Boolean algebra. Okay? So these relations are sufficient for us. Yeah, this is a question. Let me solve it. F is equals to, direct answer, I think you can guess the answer this. For this equation, x into x bar 0, xy bar, x into y bar plus y into x bar, I can write it as x bar y plus y into y bar is 0. So simply this is x XOR y operation. This is a question selected from ECET, Engineering Common Entrance Test. I already told you the Engineering Common Entrance Test questions are best suitable questions for us to prepare for SSC JE and RRB JE. And this is a SSC JE 2019 set 2 question. I will write it again. Direct question. A dot A bar from A, plus A. So from this equation, you know A dot A bar 0 plus A is equals to A, that's it. I already told you questions are very, very simple and straightforward. From the total basic electronics part, questions, all questions, digital part, analog part, EDC part, from all basic electronics part, questions are very easy, but they are trying to cover the vast area of the subject. Okay. Determine the logical operation of the given circuit. Sorry, given Boolean expressions actually. Okay. X is equals to, this is a matching type question, but as it is very simple, I took only the expressions. We can easily guess the answers. A plus B plus C plus D whole bar. What is this? Simply this is operation of a NOR gate. A, B, C and D. OR operation and then bubble. That's it. A, B, C, D whole bar. AND operation and bubble, NAND gate. It is purely OR gate. And this is a AND gate. Right. The Boolean expression given like this simplifies to. Let me solve it here. You better to solve this question, dear, and then you can compare the result. Okay. He has given A plus B bar plus C plus D bar plus B plus C bar under one complement. So F is equals to, you can directly apply the De Morgan's here. You assume this entire function as x plus y whole bar, x bar dot y bar, right? So A plus B bar plus C plus D bar whole bar dot B plus C bar whole bar, B plus C bar whole bar. Again we can apply the De Morgan's theorem here. You will get A bar dot B, B double bar, right? C bar dot D double bar, D dot B bar dot C. very simple and straightforward, as B into B bar is 0 into everything will becomes 0, right. You will get 0 as a final result. Yes. Coming to the one simple topic, of course it is a lengthy topic, little bit a lengthy unit. I am going to choose one subtopic from that particular unit, and that is an operational amplifier. We can expect 1 to 2 marks from this particular topic. Only from the operational amplifier we can expect 1 to 2 marks. And I am saying the minimum weightage, okay? And that too, all the questions are the direct questions, and you can easily understand the topic, right? An operational amplifier is basically an integrated circuit, IC, and it amplifies only the difference of input voltages. You remember that it amplifies only the difference of input voltages and produce at the output. An operational amplifier requires some power supply, and as per the syllabus we are going to study IC 741, right? And for IC 741 we need 2 different power supplies, of course 2 power supplies, positive side and negative side. And my dear friends, this is a IEEE symbol of operational amplifier, which can amplify only the difference of input. We can call it as non-inverting terminal, and this is a inverting terminal, INV, and this is non-inverting terminal. And the difference of these 2 voltages are going to multiplied by some factor called open loop gain of the operational amplifier, and it will produce at the output. And to do this work, we need some hardware internally in the system, that is the phase 1. We need to discuss about the differential amplifier, balanced input, balanced output type, next level balanced input and unbalanced output type, next current mirrors, NPN type and PNP type, and how they are providing biasing for the transistors internally in the op-amp, importance of DC level shifter in the op-amp, and the last stage, that is a buffer stage or power amplifier stage. That is totally the story about the internal operation of op-amp. After that, we will come to this part actually, right? But I am going to select a simple topic here that I can complete in just 40 to 45 minutes and maximum 1 hour, okay? So, as I told you, the op-amp is required, right, 2 different power supplies, and this power supply will help you to find the maximum positive level at output. We can say this is a positive saturation level, and this is minus Vs, saturation voltage. And remember, this is the standard equation for an operational amplifier to get the output voltage V0. Output voltage V0 is equals to open loop gain, or also called as differential gain, into difference of input terminals. I am writing it as V plus voltage at non-inverting terminal minus voltage at inverting terminal, right? This is a standard equation for the operational amplifier. But the output equations, voltage or current equations, will depends on how we are going to connect the feedback elements. And again, there are different types of feedbacks, positive feedback and negative feedback. Sir, can we use op-amp in open loop? Yes, of course. We can use op-amp in open loop also, but in open loop configuration, op-amp act as comparator. Because of its high gain and high sensitivity, output will not be linear while changing the inputs. So output will flip towards plus V saturation or minus V saturation based on the difference of input. Sir, why? Why? Because open loop gain of op-amp is very high. It is around 10 to the power of 6 under practical conditions, and under ideal conditions that is infinite. So we can't get 10 to the power of 6 volts or 10 to the power of 100 volts or infinite volts at output. There is a limitation for the output. That limitation is provided by saturation rails. This is the positive rail and this is the negative rail. Okay. And actually the terminals, this is a pin number 2 and pin number 3, pin number 4, pin number 7, and this is pin number 6 output. Pin number 6. Indeed, op-amp is a 8-bit DIP, dual in pack type IC. I will show you in the next slide. You can find the IC 741 symbol like this. You can find a notch here. This notch represents the pin number 1, 2, 3 and 4, 5, 6, 7 and 8. So you need to focus on only the pin number 2, 3, 4, 7 and 6. And sometimes even they don't give you power supplies. You don't worry, you can assume the operational amplifier is working normally. If there is no power supplies means there is no influence of the plus saturation and minus saturation voltages in that particular problem. Like that you can understand. Okay, right. And see, this is the definition. An op-amp is a high gain differential voltage amplifier. High gain differential voltage amplifier with very high input impedance. This is very important. You can expect it as a direct objective bit. I will show you that. But the question is about the value of input impedance under ideal conditions, and I will give you in an elaborated fashion. I will just explore all these things in a table. Input impedance, output impedance, and some of the specifications of an operational amplifier. Okay, and actually it amplify only the difference of input voltages as I told you, right? And the frequency range is from 0 to 1 megahertz, it's a typical value. Okay, and now the internal block diagram. If you know the basic block diagram, because the questions probably you can guess the question from the block diagram, because these kind of questions are found in ESET papers and in engineering services papers also for 1 mark, both for ECA and electricals. They are asking the block diagram, means certain block, name of the unit in certain block. And please, my dear friends, you remember this is a standard block diagram for any operational amplifier. The internal components may be different. First amplifier, for example, there is a differential amplifier. And the differential amplifier we can implement, design by using transistors. We can design it by using the junction field effect transistors, JFET, even by using the MOSFET or maybe CMOS logic, right? But maybe the bi-CMOS, but in certain locations. And entire unit may not be with the same type of transistors. But we are talking about the generalized block diagram, and for IC 741 we are using the transistors, okay? Right. See guys, this is the block number 1, differential amplifier. Differential amplifier. It can receive 2 input signals, V1 and V2, and the difference is going to amplified by differential amplifier, and it will produce at the output. The first block of operational amplifier is a differential amplifier. And the second block is also same, but to improve the gain we are using level 2 amplifier, also called as gain stage. I repeat, to improve the gain we are connecting multiple amplifiers in cascading. So this is a level 2 amplifier, also called as a gain stage. Level 2 amplifier, also called as gain stage, but it will produce only single output. Because to provide the facility, like to connect the load with respect to ground, we are converting differential input, balanced input to unbalanced. We are taking the output from only one layer, or strictly speaking, one terminal of transistor. In the differential amplifier, this is not the time to give you that. This is actually the circuit diagram. Internally, the differential amplifier circuit diagram. These two are the resistors. This is the differential output, plus and minus, V1 and V2. But if you take output only from the one single transistor, that will be the level 2 amplifier. Purposely, this amplifier is fixed here to improve the gain. Okay? So, this is balanced input, balanced output type differential amplifier. Balanced input, balanced output type. What is the second stage? Level 2 differential amplifier, I already told you, also called as gain stage. And this is balanced input, unbalanced output. Balanced input and unbalanced output, right? And the third stage must be, purposely we are connecting third stage as this is a direct coupling configuration. We are using direct coupling between first stage and second stage because it is actually the design of IC, integrated circuit. Inside the IC, we cannot fabricate capacitor and inductor, hence we are directly connecting this. So DC component also may travel from one stage to another stage. Of course, it requires more explanation. In simple words, I am telling you, to block unnecessary DC, to neutralize unnecessary DC, we are using the third block, DC level shifter. This was a question found multiple times in electrical papers. What is the block number 3? Students may probably give the wrong answer. Level 3 amplifier, it's wrong. Third block is a DC level shifter. And the last block is buffer stage or is a power amplifier. Buffer stage or power amplifier. And finally, this is the output. If you take this entire system into a single IEEE symbol, you will get this. Okay? So, this is about the basic internal block diagram of a audio amplifier and the two IC type. IC stands for integrated circuit. Now, coming to the pin diagram, I already told you, I already given this actually, but this is a pin diagram, names are given clearly. Pin number 1, pin number 2 inverting, pin number 3 non-inverting, and pin number 8 is the output. Pin number 7 is plus V saturation and pin number 4 is minus V saturation. Actually, there is no use of pin number 8. Pin number 8 is given as NC. NC stands for not connected. This is not connecting to the circuit internally. And pin number 1 is offset null, or we can also take it as offset ground. Strictly speaking, this is a ground. And pin number 5 is also offset null. We are using these two terminals for some special purpose to neutralize the error voltage or offset voltage. You better to remember the pin names also, pin numbers and name. They don't ask you anyways about NC. So you need to memorize inverting, non-inverting, output terminal pin and what we call plus V and minus V saturation terminals. Okay? Right. And coming to the different configurations. And see, my dear friends, this is IC741. You can find some sequence as we are studying about IC741. It might be like LM741, MUA741, or otherwise like MC741. We can find some sequence. Sometimes they can ask the questions about these things also. Sir, how can we memorize? No need to memorize all. There are some standard companies you better to memorize. LM stands for linear monolithic. And this sequence is registered for certain company. Of course, National Semiconductors. This is a question given for electrical paper, but that is a BTech based Genco paper 2012 AP Genco. But this is a chance to ask you the question like this. So safe side, you better to remember these things. LM stands for linear monolithic. Okay, and it is belongs to National Semiconductors group of companies. National Semiconductor. You can find the IC number see here LM741 and here RCA, but you can find the IC number like simply CA741. RCA stands for Radio Corporation of America. Radio Corporation of America. Mu A, they don't ask you the question about it. Why? Because Mu A stands for, of course, it's a micro amplifier, belongs to Fairchild company, but these patent rights are given to some other companies also. Okay, but originally it was belongs to the Fairchild. MCA, MTT, MC, MT, all are belongs to Motorola group of companies. Example, you can see like M by C also, M/C 741, MC 741, CA, MCA 741, MTT 741, like that it is belongs to the Motorola. Please you try to note down each and every point, right? This is actually the preparation strategy. You should understand how to read a subject. From line to line you should guess, you should understand how the examiner can frame the questions on this particular topic. That means we need some hard work, I'm not saying hard work, okay, hard work with some smart work. Then you can simplify the preparation. Okay, only hard work does not give you the success every time. Along with the hard work, you need some hard work, right? Then only, because, and that too, you should love what you are doing. As you are preparing one subject, you should understand and you should try to own that subject. You should feel like a research, right? You need to read the subject from morning 6 to evening 6. Spend 2 hours for one topic. After that, spend 1 hour for previous year questions and 1 hour for the objective questions which are provided backside of the textbook or otherwise any material. Like that, you just try to practice the subject in the sector wise. And then after completion of the total subject, you try to go for the short notes and revise it once or twice and then test yourself. By preparing some questions on a paper or otherwise by downloading some mock test papers, you try to test yourself. Okay? But while reading the textbook, if you read simply line to line, no use. While reading the textbook, you should write some important highlight points just like a bullets. Okay? Then you can prepare the material. You will get your own material. Okay. Yes, coming to the specifications of operational amplifier. See, my dear friends, as the internal circuit of operational amplifier is differential amplifier. Remember, it always amplifies the difference of voltages. Each and every specification is having its own reason, and actually we need to go for the internal circuit and current mirror concept to understand it. But for us, no need. You remember one point. Basically, operational amplifier is a voltage amplifier, voltage control, voltage source. It is taking the voltage and giving the voltage. Sir, if I want to get the current, sir, that depends on the feedback. How you are connecting the load will decide it. And I am talking about the basic nature of op-amp. And the operational amplifier input impedance is very high. The input impedance of operational amplifier is very high. These are the main important specifications. And under practical conditions, they never ask you, very rare case, of course. Ideal specifications are very important for you. They keep on asking the ideal specifications of op-amp. Sir, what are the specifications or characteristics of op-amp, sir? The characteristics of ideal and practical, of course. Ideal characteristics of operational amplifier: input impedance, output impedance, open loop gain, that is a differential gain or voltage gain. Okay? Open loop voltage gain, slew rate, and CMRR. CMRR stands for common mode rejection ratio. So after completion of these things, I will go for some basic explanation, circuit level analysis. Okay? So as I told you, the input impedance of op-amp is very high. You remember, very high, ideal case infinite, very low, ideal case 0, that's all. You should know there is one specification or characteristic of the op-amp. what should be the value, low or high? If you could able to guess, yeah, it should be low, then ideal value is 0. No, it should be high, ideal value is infinite, like that. And the input impedance of op amp is high and output impedance is low. Output impedance of op amp is very low, right? As the input impedance of op amp is very high, you remember, my dear friends, current entering into op amp is always 0. Current entering into op amp is always 0. Right. Now I am writing that characteristics. He has given like specifications. Input impedance Ri. Input impedance Ri. Output impedance R0. Differential gain, also called as open loop gain of the system. Differential gain or open loop gain. CMRR, common mode rejection ratio, and then slew rate. Slew rate. Under ideal conditions, input impedance of op amp is very high. I already told you, my dear friends, ideal specifications are very important. And in spite of the number of op amp, the ideal specifications are valid. And all the disparate things, whatever that I am going to write on board under ideal conditions are valid for any op amp. Under which conditions? Ideal conditions. But practical conditions, whatever the values I am going to write, those values are valid for 741 op amp by using transistor. 741 IC 741 operational amplifier fabricated by using the transistor. Okay, right. Input impedance very high, so infinite, units ohms. Output impedance very low, 0 ohms. Units ohms, no need to write, of course. Volt for volt, voltage gain or differential gain or no units. Under ideal conditions, the open loop gain or voltage gain is very, very high. And CMRR is also very high. CMRR stands for common mode rejection ratio. Slew rate. Slew rate is a special topic, of course, very important, but this is the last topic in operational amplifier. It will come after 8 hours of operational amplifier, 8 to 10 hours of operational amplifier. Last 2 hours topic is about practical op amp. There we need to discuss about the slew rate. Okay? And the slew rate is also infinite. Volts per microsecond. Units of slew rate is volts per microsecond. Coming to the practical specifications, these are very important, guys. Ideal specifications. So many times the questions are found. Okay? Coming to the practical specifications, input impedance is very high. It is in the order of mega ohms. It is in the order of mega ohms. In the order of mega ohms. Output impedance is very low. It is in the order of ohms. Why I am writing? In some exams questions are found like this. But the values, we need to go for the typical values. There is a range actually. It is around 1 mega to 2 mega input impedance. But I am writing 2 mega ohms. As per IC 741 using transistor, nearly. Output impedance is nearly, you can find in some books it has given as 5 ohms also. Very low, it is in the order of ohms, I am writing 20 ohms. Differential gain, I am taking the star mark here. This value is a standard value you need to memorize. I am taking the star mark here also, my dear friends. For all ideal values, you must remember. Okay? And practical case, you need to remember differential gain and CMRR are numerical value. This is 10 to the power of 6. Volt for volt are no units, voltage gain only. Differential gain or voltage gain or open loop gain of operational amplifier under ideal conditions, infinite and practical for 741 is 10 to the power of 6. Here also I am taking star mark, my dear friends. CMRR, common mode rejection ratio, is 10 to the power of 5. And if you see the slew rate in different textbooks, the values are given in different ways, but for 741 using transistor, the value is 0.5 volts per microsecond. I am not writing the remaining. By using JFET, junction field effect transistor, its value is 10 volts per microsecond. For MOSFET, 100 volts per microsecond. But you remember only this, 0.5 volts per microseconds. And the operational amplifier can operate in different configurations, my dear friends. The op-amp can be operated in 3 different configurations. And the broad classification will be like open loop configuration, and closure loop configuration. Open loop configuration and closure loop configuration. And in closure loop, there are 2 types based on how you are connecting the feedback. Closure loop means this is under or with feedback. Feedback, taking some sample from the output and connect it at the input. Sir, how can you take and connect, sir? By using the resistors. Sometimes maybe capacitors and inductors also can help us to take the sample from the output and mix it at the input. So feedback, how you are connecting. Based on the orientation of sampling and mixing, in closure loop, amplifiers are again classified into 2 types. Those are positive feedback and negative feedback. %95 of our topic, 95 to 98% of the topic is about negative feedback amplifiers only. In negative feedback, we are using the op-amp as amplifier, and in negative feedback, we can find different applications for the operational amplifier, such as integrator, differentiator, different types of filters, logarithmic amplifier, anti-logarithmic system, precision diode. There are so many things. You can find all these applications under negative feedback. Not only that, different types of amplifications, addition and amplifying that sum, subtraction, amplifying that difference. That means adder or summer and a difference amplifier, buffer, all these applications are found under negative feedback. In the open loop configuration, operational amplifier act as buffer. One second. In open loop configuration, operational amplifier, we can use it as comparator. Again, there are 2 types, inverting and non-inverting comparator. Based on the situation, I will explain it. But in open loop, finally it acts as just like a comparator, and accordingly the output of the system will be either plus V saturation or minus V saturation, and sometimes it may be 0 if inputs are same. Okay. And in negative feedback, I already told you, but positive feedback, there is one question, there are 2 points you need to remember. Of course, we can use the positive feedback for different applications. Just example, I am telling you, multi-vibrators with the help of Smith trigger. But I can't explain all on the same screen, right? So, positive and negative feedbacks. Just I am writing FB. And my dear friends, in positive feedback, we are going to design, if time supports, I will give you the circuit. We can implement a buffer, we can implement a Smith trigger and then I am directly writing its name Schmidt trigger. It is not a square wave generator, you remember, they are asking the questions like that. Square wave generator is different. Square wave generator, if you want, means it is an S-stable multivibrator. To get S-stable multivibrator, not only Schmidt trigger, we need extra RC circuit. But a Schmidt trigger can convert any other waveform, let us say sine wave at input, into square wave. It is just like a converter, not the generator. Okay? So in the Schmidt trigger, we are using the positive feedback. And the negative feedback we are using in negative feedback configuration, op amp can be used as amplifier. This is enough. Once if you design an amplifier, you can find different applications for that. Coming to the open loop configuration. What is the gain of the operational amplifier? 10 to the power of 6. For example, if I connect this negative terminal to ground and a positive terminal 1 volt, then what is the output voltage V0? This is the time to use standard equation I have given already. What is the standard equation? Output voltage V0 is equals to open loop gain into non-inverting terminal voltage minus inverting terminal voltage. What is the open loop gain? 10 to the power of 6 into what is the V plus 1 volt minus 0. So what is the output voltage, sir? V0 is equals to 10 to the power of 6 volts. Output voltage V0 is equals to 10 to the power of 6 volts is wrong answer. Please remember, energy neither be generated nor be destroyed. Then how can I say for 1 volt of input the output is 1 megavolt, 10 to the power of 6 volts. How it is possible? Practically it is not possible. Sir, why? The output voltage will be under the control or limited by, I already told you in the beginning, 2 power supply rails such as plus V saturation and minus V saturation. Sir, what is the range of these voltages? As per 741 IC, we can provide up to plus 18 and minus 18. Safe voltage plus 12 and minus 12. Output will be saturated. We are expecting the 10 to the power of 6 volts, but it doesn't provide say 10 to the power of 6. It will be restricted by plus V saturation in the positive side and minus V saturation in the negative side. Simply in this case, we can say op amp is saturated. Op amp is saturated. So output will be, if it is plus 10 minus 10, output will be plus 10 volts only, right? So that is the reason. If the non-inverting voltage is greater than inverting voltage, non-inverting minus inverting we are doing, right? Of course, not we are actually, it's a duty of op amp, and op amp is always comparing the voltage, the difference like non-inverting voltage minus inverting voltage into the open loop gain. If the difference is positive, non-inverting is greater than inverting, output will switch into the plus V saturation, and in reverse case, if the non-inverting is less than inverting terminal voltage, output will switch into the negative saturation. If they are same, obviously the output voltage is 0, you can find a discontinuity line over there if you take the graph, right? So that if I take this as V minus and this is V plus, what will be the output voltage? V0 under practical conditions. Even under ideal conditions also this is same. You can write it as V sat, I am just writing Vs. If non-inverting terminal voltage is greater than inverting terminal voltage, that is one case. Non-inverting terminal is dominated by inverting terminal voltage, that is the second case. Sometimes you can find the coincidence, that is the third case. Output will be plus V saturation, and here the output voltage V naught is minus V saturation, and here the output voltage V naught is equals to 0 volts. If I take the rough sketch, transfer characteristics, difference negative, and if the difference is positive. What about the output voltage? V naught okay. If the difference is positive, you see output will be saturated, plus V saturation. If the difference is negative, minus V saturation. This height is plus V saturation, and this height minus V saturation. And this discontinuity will give you the voltage. Of course, when they are same, output value is 0, right? So this is the transfer characteristics of a op-amp in open loop. So in open loop, I can say op-amp can compare the voltages. In this case, we can also call it as 1-bit quantizer. 1-bit quantizer. And this is a point you need to note. In open loop, op-amp can act as, in open loop, op-amp can act as comparator. This is given, and this is also given in exam. 1-bit quantizer. Right? You got 2 objective bits from here. And the third objective bit, this is already given in SSC JE paper. You take one operational amplifier, connect one terminal. You can choose any terminal, no problem. Inverting terminal is ground. And a non-inverting terminal is connecting to one sinusoidal signal. Let us say this is 5 sin t. What is the output? Straightforward question, very simple. Let me take the sinusoidal signal like this. What is the output? This is not the difference, okay? This is just one of the input at a non-inverting terminal, hence I am writing it as V plus, positive and negative cycles, half cycles. What about the output? And in open loop, op-amp act as a comparator. Then please, my dear friends, you need to guess this. What is a inverting terminal voltage? This is remains constant at ground level or 0 volts. So very simple, we can take the decision like this. If this is V plus 5 sin t plus 5 and minus 5, if V plus greater than 0, what will be the output? If V plus less than 0, what will be the output? That's it. Just it is, the signal is being compared. V plus greater than 0, output will be positive saturated. And here minus V saturation. As the 0 volts is the reference, that is a 0 crossing point, output will be 0. Very simple. So, this is a 0 crossing point. Like this. Plus terminal greater than 0 here, output is plus V saturation. Plus terminal, positive terminal is having negative voltage, as compared to 0, this is less. 0 is more than negative. So, as a positive terminal value is less than 0, output will be minus V saturation. Like that, you will get a square wave at the output. You will get the square wave on time, and this is off time. Even next time they may ask you duty cycle 50%. On time is equals to off time. On, and this is off state. Right? So, the output is square wave, triangular wave, always 0, always plus V saturation are the options, and the output is square wave. Square wave is the answer. And what is the formula for duty cycle? On time by total time. Generally they ask you in percentage. So, on time is equals to off time. So, if this is Tx, this is 2Tx, 50% duty cycle, right? But question is about the waveform only. For 2 marks, we can go for more complicated questions. They can give you some reference voltage here, like, and some with resistive combination, they can frame some circuit here, they can give something, they can ask you the duty cycle. For us, no need, 110% no need. For 2 marks, we can find such type of questions. For 1 mark, this is only the chance, okay? Right. And coming to some of the important observations, we need to go for some standard points of operational amplifier if you want to start the analysis. In that, the first one is, current entering into op amp is always 0. You remember this point at any cost. Even with the feedback also, you remember current entering into op amp is 0. Why? Why? Because the input impedance is infinite in op amp. So that is the reason current is 0 amperes. Input impedance is 0 or infinite ohms, right? 100% of the times they can ask you the numericals based on ideal specifications. So you need to go through the ideal data only, okay? And one more important point, actually it requires more time, but I want to give you in simple way. Virtual short. Please you remember this point carefully and very important, of course. Virtual short, you better to write the statement also. As per the concept of virtual short, there are so many limitations also, but for us, we need the basic idea more than sufficient. Only you remember one limitation, that is, first you should know what is a virtual short, then that one important limitation. And the point is, according to the concept of virtual short, whatever may be the voltage which is available at non-inverting terminal, the voltage can be reflected at inverting terminal. Voltage from non-inverting terminal can reflect at inverting terminal. But this is a big story why these two are virtually short circuited. Whether they are practically maintain same exact value or there is always some error. This is the background story. But error amplification is a loophole for this particular topic. But you just remember, you don't worry about all, you just remember. In operational amplifier, voltage from non-inverting terminal can reflect at inverting terminal. This concept is generally known as virtual short. Sir, if this terminal is ground, sir? Yes, the ground or 0 volts will reflect here. In that case also, that is virtual short only, also can be called as this is ground, you can also call it as virtual short or virtual ground. In second case, you can call it as virtual ground. But the condition is, I am writing virtual short as simply Vs. Virtual short is applicable. Virtual short is applicable for negative feedback configuration only. Virtual short is applicable for negative feedback configuration only. And if you see the engineering related textbooks or engineering, strictly speaking, qualification based exams, you can find some complicated questions. Of course, this is a complicated topic. Within the negative feedback also, there are some limitations like gain should be high, input impedance, so and so. There are some conditions. If you go through all, it will kill your confidence. So, we need to ignore all unnecessary areas as per our syllabus and as per our questions level. Okay? Only one point you remember, virtual short meaning. And second point, in which case the virtual short is applicable, in which case negative feedback case, and in which case it is not applicable, two different cases. I think by this time you may guess it. In open loop configuration and positive feedback configuration, we cannot apply the concept of virtual short. Virtual short concept applicable only for negative feedback configuration. That's all, right? This is a simple and straightforward point. Right. And at least I'd like to solve one question. Okay, one question. See, this is a source voltage. Let us assume this is R2 and R1. The question will be like this. Consider the circuit as shown in figure. Find the voltage gain of the system. Find the voltage gain of the system. I already told you, you need to follow all the rules and regulations carefully. You need to follow all the rules and regulations carefully to answer this type of questions. First point, whether the system is connected in negative feedback or not. Yes sir, correct, tick mark. Now, if it is connected in negative feedback, if the system is connected in negative feedback, we can confidently apply what? Virtual short concept. According to the virtual short, this voltage can reflect at this node. Then next point, current entering into the op amp is how much? 0 amperes. You remember that point also. As there is no entering current here, we can directly focus on only these two branches, that's all. We can directly focus on these two branches only. This is a node, we are going to find the output voltage V0. There are two different ways to analyze and answer this question, KCL and nodal. What is the voltage at this node? Sir, voltage at this node is Vs. That's great. Then we need to apply the nodal. Vs minus 0 by R1, R2, R3, whatever may be, right? Plus Vs minus V0 by R2 is a nodal. To understand the operational amplifier and basic electronics part, only the basic subject, supportive subject is network theory. If you are good in networks, you can play with basic electronics. You can say it is 1 by 2 offer. It means if you are good in networks, you will get around 10 marks. And you can easily get around 4 to 5 marks from analog with the fundamental knowledge of network theory. Because here, except the specifications and some related things of op amp, if you see any circuit, every circuit we are going to solve using networks concept only. Sir, you said KCL, sir? Yes, of course. What do you know about KCL, my dear friends? Entering current is equals to leaving current. If I assume some current is entering here, the same current has to leave through R2 because current entering into op amp is 0. 0 minus Vs by R1 is entering current is equals to, what is the leaving current? Vs, this is Vs, minus V0 by R2. Like that also you can solve it. I am writing the node equation. I am doing nodal analysis, NDA. What is the voltage at this node? Vs. Minus 0 divided by R1 plus Vs minus V0. Vs minus V0 divided by R2 is equals to 0. Vs by R1 plus Vs by R2 is equals to V0 by R2. Vs by R1 plus Vs by R2 is equals to V0 by R2. I want output voltage V0. Output voltage V0 is equals to, see this, bring this R to this side. Vs is common. Vs into R2 by R2, 1 plus R2 by R1. R2 by R1. The voltage gain of the amplifier AV is equals to output voltage by input voltage. So, what is the voltage gain relation for this amplifier? 1 plus R2 by R1. And this question is given like with the same values of R1 and R2, voltage gain of the system is equals to 2. R2 by R2, 1 plus 1, 2. This was the question found. I already told you, very simple, basic level questions, right? Don't go for the complicated questions, but you should learn the entire concept. I already told you it is a 70 hours subject, okay? 70 hours subject. And just in the live sessions, we are giving some just basic idea how to read. If you select one topic, how to read, how to guess the questions, and what kind of questions they are asking, that just trigger your preparation, okay? That is the reason actually we hope that these sessions will definitely help you. And in the next session, we'll go for the continuation part. There are so many amplifiers, and then only we can touch the numericals. Without knowing the basic idea of all the types of amplifiers, we cannot understand the problems, right? And let us stop here, and all the best, my dear friends.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESC 2020 and ESC 2021.